Welcome to class 20 of Python programming, and this will be fifth class of object-oriented programming. Now, if you see here, we have a class D, and then we have another class here. This is one class, and this is the other class. Let me not write all these things. So it's very simple. Okay, even if you want, I can make it more simple. If you forgot about this one just we can write so that we can print this variable, x variable. So whatever is x, that will come here. X will come here. See, x is here, that will come here. So you have a class D, and in class D, we have two init methods. So if you have two init methods, then what will happen? Suppose you send 10 here, and you try to run this, you will get this one or this one. You run it and check. So when you run it, you got 10, that's fine. But you got here, this one you got, not this one. Because what will happen is, you should not have more than one in it. In that case, what will happen? There is something called overriding. The second time when you get, this will get erased. Okay, you can check, you delete this one and run it once again. You check now, you got one. Okay, so you got one here. If you have another init, then there is no use of writing this. By chance, if you have two init initialization function, you can delete the first one. It's not required. Now I deleted the second one, so I have only one. Yeah, it's simple now. This way you can write, you'll get this. This is over. Then the second one, we have a lot today. These many. I'll try to complete because I fixed 5 classes. This is over. Then the next one is the same type here. A is class. Here this is child. This is parent class. This is child class. We've written A in the bracket here. So through A, I mean, when you call this class, okay, then you have access to A also. Now suppose I'll write B is B10. Then what will happen? Just a minute. So here we have another class, that is subclass. This is the child class. This is the parent class. Now if I have an object B here, if I run this, what I should get? Here this is child, right? So now B is the object. So now 10 is here. 10 will go here. And then this will be printed. Remember, this F is nothing, okay? Even if you want to print only X, you can print like this also. All things are not required. If you by chance forgot that one, you can write X. You will not get everything, only you will get X. So this is one way. We have dot format also, but I always use, this is the best one. You just write F here. Within quotes, you write whatever you want to write, whatever, and the variable you write within curly brackets. What will happen? the value of x will come here. Now constructor 2 with arguments x. So we got this one. Now the question is, can you go here? Because when you are creating this b is equal to b10, so b is the object of child type, so you are here only. How can you go here and access to this? Why accessing the variables is important? Suppose I'll write a function here, def, any function you write. Let me write self. You just print x here. Will it work? Self.x. And we'll call this function. See, if you are wondering what I'm doing today, let me tell you that last time I didn't use this one, the initialization. Today, with initialization, we're seeing child class and parent class. Last time I gave you one example where initialization was not there. Now, okay, let me call this function b dot fun. I can call, right? Because when you are here, you have access to a also. So whatever functions you have, you can call. Because I'm not sending anything here, I can just write this way and see what we're getting. It says, okay, see now, B object has no attribute X. That means it says B object has no attribute X. That means what? Anyone? See, I will show you the problem. It says B object has no attribute X. But 10 is there, right? We printed 10 also. But how B has no attribute with X? Did you forget one line here? Okay. Let's write self.x. You have to write this. See, I printed X here. Because X you are sending, that's here. But where is this initialization? I mean this the assignment statement. X has no meaning here. With self.x only you have to do everything. So this is must. Now run this one. If you run this one, you see we got constructor 2 with arguments 10. Okay. 2 means second constructor. This is called constructor here. So argument 10 is here, that is there we printed. So through this we went here, we printed this. There is assignment this also. So the 10 goes here, self.x. Now you printed self.x here. When you call function through self, you printed self.x. This is accessible because it's here. Now the question is, suppose I write here as well, self.x is equal to x. Which one it will take? This self.x it will take, or this self.x it will take? That is the question. Which one it will take? Suppose we write self.x is x plus 1. Okay, we can write this way, not a problem. Self.x is a variable which is whatever you send here plus 1. That is possible, not a problem. Okay. Now if you give this one, you see this one will be printed. That way only you can check, right? Self.x is here, it's here. So if you write x plus 1 here or something other than x, then if you run it, you will be able to know which one it prints. So this self.x value is 11. Okay. So it took 11. This self.x has no meaning. You print here. So you are not getting anything of this. Okay. See, we call this function. In this function, whatever is required, these things are supplied from here. From here. It has no connection with the initialization thing, because we are not getting constructor 1. We are not getting constructor 1 in printout. We are not getting this as well. So we are not going here. You have no access to the initialization method of the original class. Whatever you have here, with that you are calling here. If you by chance compare with the last class, in last class I didn't take initialization method. That was simple. So you can't go to this one here. So there is a way you can go to these values also. This INIT you can go. That will do. Let's continue. Now here you have import math, because we will use here math dot square root s into s minus a, s minus b, s minus c. And the values are there. S value, you know, this one. It's better if you write self.s. With s also we can do. There is no problem. But if you want to get access outside value of s, okay, then you have to write self.s. It's always better to write self. Okay. Yeah, let me write a bracket also. Now, this is triangle, and area is a child of area is one function we have defined here. Then T1 is a triangle. These are the values. You just print area. Okay, whatever area is. This is simple. Now come to equilateral triangle where all are equal. This is obviously a child class of this one. So in equilateral triangle, all are equal. We don't need to supply 3 here. So we have written only 1 here. And when you create T2 and when you send 10, it will go here. And from A, you can get B and C. So you have ABC. Now these ABC values, we are sending to this here. How? Forget about this one now. If you run now, this one is there, okay? This one will not use. Now, if you Control Z, let it be, we'll get this printout as well. Then here, now ABC you have, you are sending ABC here, okay? And then you will get the print. Check here now. So super parenthesis you have to write. This is the function, okay? super class, you can say. Now there is a problem. S is not defined. Okay, S is not defined. We must have written S somewhere. Yeah, everywhere we have to write self.s. No problem. S is not required. Just keep it this way. Now see, we got 24. 24 from this one, area of a triangle. These are the sides. Now from this one as well, we got area 43 point something. Okay, this is area of equilateral triangle. But where you found area? We found area. We have no function here. So we found area. We called area equilateral triangle. We called this area. Area is not in the subclass. Area is present in the parent class. So this area here we found the area using this. So we have written import math also. So math dot square root s into s minus a, s minus b, s minus c. This is the formula. So we got the area. Now area is not present in the child class. Area is present in the main class. So when it's present in the main class, the parent class, you should have access to all these self.a, self.b, self.c. These things must be there. Even if I write print, let me write print self.c. You run it. Now I've added print self.c. If you see, I got 15 once and then 10 once. How you got 15 and 10? Where you got 15? See, we have to cut these two now because that will create problem. This 15 initially when we call this one, then we got 15 here, okay, through this one. So let me cut this one. This is no more value here. So if you check this one, here now no value. We didn't send any value to this, okay. Now where you get these values? Because you have not given any value to this. And here you got, see 10 you got and 43.30 you got. So 43 is what? You got the answer area this one. And these values ABC all are equal. So all are equal means you are getting equilateral triangle area, but through the parent class. So parent class is here. The formula is applied here. So if you, we didn't send any values. So how it's possible? These values through super function here, super dot you need to write, init. Through super you can get access to these variables. So these three are now present here. These three, these are present here. We checked also, we printed self tc. See, we didn't call this, we didn't make an object of the parent class because I got that one now. So last time 10, 15, whatever we sent, but now nothing is there. So directly we have only a child class object. From that we are trying to call the parent class function. That's fine. But where you get the variables? The variables are picked from here. These variables went here. If you say no, last time also, what is the problem taking from here? What is the problem taking the variable directly? Suppose I will not write this. Okay, you run it. Equitriangle object has no attribute A, it says. Okay, no problem. We'll write self.a, this is okay. Then again no b, so all you have to write, no problem. Let me write self dot b, self dot c. A I can write, not a problem. Okay, so all are A because all the sides are equal. Run it. Now see, we got this answer, that's fine. So these values self.abc, when you call this one, they are available here. So everything we have, S is defined specially. So you got the answer. It's no different from the last problem I discussed already, if you remember. Now my question is, do you have these values till now? Because what will happen is, if you don't have these values, because there is no parent object here, then you will not be able to use all this. So we checked by writing print self.c, but we didn't get any answer here. If you check, no such thing we got. So again, we are using only this part. It's not going there. But if you write this one here, if you write this one here, you get a printout. 10. 10 we got from this one. Now, if I write this way, if you check the super class thing, there is no initialization here. This one, same thing, let me write here, will not get, okay? You run it. So 10, 10 you got. Here we call this one. This went here and BC both are there. So self.c, because we sent everything, we have written this one, all the variables ABC, now they went here, okay? And through this one, you are getting the printout. If you got this, you see, you will not get that value now. So that means that is working now. See, we got only one. We didn't get this one. Okay, this one disappeared. So remember, if you want to go to this function, then you have to write the super. So I'll send you this file also. There are many problems, so that will be helpful to you. If you have any problem, you can revise once again. Now go to the next one. Again, use of super. Here we used once again. It's not a different problem. Same, you have computer parent class and mobile class. Then computer is here. Here we have initialization method. Here we have initialization method. So because when you have only this class, child class, whatever attributes you have here, that will go here. If you want to access these things, here if you want to initialize, this is the way. Super dot init computer. Remember, there is no self, nothing, just super dot this, and within that everything you need to write. So then you write this Apple is mobile type, so apple dot computer RAM, whatever you write, these values you get. And you see, again, when you write apple dot computer, this is not a method, this is an attribute. There is no method here. When you write apple dot computer, apple dot computer means self dot computer, that value here, because we are using this init method. Computer, RAM, storage, all are there. Even we didn't write any print statement here. Still we are getting the answer. How? We have not written any statement here. We are getting all these answer not through this in it, but through this in it. That's what we wanted to verify. Because Apple, we have written computer, apple.computer. Now suppose I cut this one. Then what will happen? You can check this one as well. See, mobile is no attribute computer. So this is over now. Let me go here. Here we talk about parent class with two child, one parent, two child, two children. One parent, class with two children. Now this is our parent class. We have written name Harish and one function. So just print it, parent name here, and then comes son here. So obviously it's a child. Here also we are not doing anything, just the name and print it. Then daughter class, here also parent, and just you need to print here. You have to write this anyway, then print it. Now if you check, you have one object S1, son type, D1 is daughter type. So both, if you see, both have the same parent. Parent is here. So one parent, two children. This is inheritance, but not multiple inheritance. Multiple means two parent, one child. It's like father, mother, then one child. Here, one parent, two children. So it's not multiple inheritance. It's only inheritance. If you want, I can write here. So we have two objects here. The objects are S1 and D1. Then if you run this one, so parent means it is direct link with this one. So absolutely there is no problem. So parent you are calling, and it should print parent name. Harish you have written, it should print. And then so child. So when you say so child here, that is present here. So it should print this one. Okay. Similarly here also two times through, this parent and child, you will get these two. And then you will get these two. Check here. One parent, son is Amit. One parent, son is Harshita. So there are three in total, not four. Now if you check this one, this is a square. You have area, perimeter. These are the two methods here. And then this is child square. And here S square we have written. Yeah, S square. Parent square, P square I wanted to write. Anyway, not a problem. Here this is child square. So what we are doing is we are checking when you create a child square with 4, here 4, and you see if you call area is present here, area is present here. See which area it will take. The problem is when always what we do is The child class, from child class, you have an object. So you can call the function or methods of the main class, the parent class. That's fine. Now same type of thing is present here as well. Area is present here as well. So when you call area, it will take this one or that one. That's why I've written one more here. So length into length, whatever will send, 4, 16 plus 1 I've written, so that we can check whether this one you will get or this one from this one you will get, from the parent or from the child, if they are common. Okay, so run it. Now check here, 6 we got. So 4 is here, 4 plus 2 we got here. So this printout you are getting here, first one. Then length into length plus 1, that is 4 into 4, 16 plus 1, 17 we are getting. Okay, and perimeter is not here. Perimeter is not here. That's why you are getting from here 4 into length. You will get 16 here. 4 into 2, 8 here. 16 here. 4 into 4, 16 here, because perimeter is not present here. So if something is present here, then you will get, you delete this one now. Run it. See, now there is no problem. Because you don't have square here, it will take, the call will go here only, and you will get this, and then perimeter this. So both are present here. So that you need to know. The second one is, now we have a rectangle and we have area, perimeter, same thing. Instead of square, we have written here rectangle here, and instead of child square, we have written square here. Square is one child of rectangle, we can say. It's a subset. So rectangle is higher class. Now here, again through super, this length and length we have written here. Because we are talking about square here, we forget about this one now. We're talking about square here. In square, both are equal. Okay, so length and length we have to write. We need not send 2, because this is square type. This 4 will go here, and length we have written 5 here. So you print here, and then through super, these two will go here, length and width. Okay, both here length and length we have written. So this is length, this is length, they are the same. So you check here now. What more? Achha, here also there is one area. Here I have written 101, so that you can check. Here area I've written 1. Okay, you can cancel this, not required. In one place we can write and check. Now if you check here, see, we got 5 square dot area. Area is here. Sorry, we are, yeah, this one only. Okay, so when you call this area function, here we have a printout. That's why we are getting, how many printouts we have? Because through super also you will get one printout. Here self dot length printout 5, because you are calling this this class, right? This one. So you forget about rectangle until and unless it's required. Now you are here, length you have defined, the length whatever plus 1. So 4 plus 1, that is 5. Now through super, okay, you have access this one. Then only there is a call, okay, square dot area. Later we'll go to this one later. Through this, still this is not over, because when you create an object, initialization method of that object, it doesn't matter it's a child or parent class, This all things will happen automatically. So through super, the length and length, whatever 4 is there, they will go here. Okay, 4 4. So you have self dot length, self dot width. So now print self dot length. So this printout you got here 4, but here you got 5 because we printed this plus 1. This plus 1 we have taken here. That's why you got 5. There we have just taken length, so you got 4. Nothing. One printout we have. So this work is over. Now this work is over from the child class. Because we created child object, this work is over. Through self, through super dot, we went there and we printed one statement. If you write 5 statements here, then also all will be printed through super. And direct printout is there, so we got 5, 5, 4. Then when you call this area is present here. So I have written 101. You check, I have a big one, 117. So again we are here. So 2 area are there, but perimeter is not there. So it will go here, 2 into length into width. Length to width are different here and there, right? Here for length we have added 1. There length to width both are 4. 2 into 4 plus 2 into 4. That way you will get the answer. Okay. 2 into 4, 8. 2 into 4, 8, 16. That's fine. Now if you check this one, yeah, it's the same, I suppose. This is not required. Now comes multi-level inheritance. So that was inheritance. Now multi-level. Multi-level means 2 parents, 1 child. Now we have 1 parent. Then we have class B. This is one type I'm saying. We have, it's like grandfather and father, then child, that way. Okay. So B is a child of A here and C is a child of B here. Now only we are printing, hi, I'm from class A, hi, I'm from class B, from class C, that way. Then what I've done is I've created one object C type. Okay. I've created C type. Now then when I call this function, I'm calling this function C dot this one. Then if you see, I'm getting hi from class C. Hi from class C. This is the printout. I can call from B. This one also I can call. There is no problem absolutely. So if I call this one, I will get this printout. Okay, the second one. If you call this method A, so through this one, through grandchildren, or you can say the child, you can go to the father and grandfather also. So here, hi, I'm from class A. If you want that, you can call that function. Okay. This is multi-level. Then multiple inheritance, another type. If you see, suppose A here and B is here, 2 classes, and then C is a class where we have 2 parents. A and B are parents. Suppose A is father, B is mother. Okay. Multiple. This is multi-level. There is a difference. Remember. So we have class A, class B. So suppose A is father, B is mother, and C, A, B. A, B, both are there. With comma you need to write. We have not written anything. Now C is, see, if you don't want to write, you need to write pass. Otherwise there will be problem. Now C is of type C. Now C dot speak means it will go here. Speak dot scream means it will go here. Speaking, screaming, right? So what will happen is you have one child with two parents. This is very simple, straightforward. Now the problem will come here. Same type A, B, both are same now. See here both are different. Some others they do it, that's a separate thing, but here both speak. Father and mother both speak here, and class A speaking, class B speaking. Now CAB, if you check here, if you call speak, where it will go? Class A or class B? Because both are the parents. You are see the child, okay? Now when you call it, when you call speak, where it will go? Here or here? That is the question. They are both different. Now both they look the same. So here what will happen? There is a precedence. A you have written here. So this one will be printed. A is speaking. If you change B, if you swap A and B, then things will change. So remember, this will depend on this order, how we have written. So you will get this answer. Okay, now see the next type. Here both are same. Okay, this one is also CAB. Speak self, print C is speaking. This is a new one. Okay, that was not here. You check here. AB we had with nothing in C, pass. Now we have something in C. We have something in C. Now if you create a class, if you call this function speak, what will happen? Class C speaking will come. See, when you go to these two, if you don't have that present here, if you're present here, then you will get from here. If not present, then you have to choose between A and B. The precedence is A will get first chance, you can say, then B. If you swap, you will come here and not go there. This is one type. So C is speaking here. Now go to the next type. Here, class A, class B pass, and class C is here. See now it's slightly different. Class A is here, B is a child of A. Now if you go to C, C is another. How many we have? B is child of A, C is one, normal one. A is a class, C is a class. Two classes, two fathers. This father has no, no son, you can say, no child, but this father has child B. Okay. Now D, B and C are parents of D. D is child of B and C. B and C. Suppose B is the father and C is the mother. Okay. So we're talking about a mother, we're talking about a father whose father is A. This way. Now we're not writing anything, and now you call test. Here MRO test, here MRO test. Where it will go? Now if you go by the precedence here B and C, it should go to B. Okay, there is nothing in B, that's the problem. Then what will happen? Will it go to C? If it will go to C, you will get this one. If it will go to A, you will get this one. So that you need to think. You got A here. You got A here. This one or this one. If you think that B and C are there, okay. If you go by that one, B is here. You go to B, nothing is there. If you go to C, this should be printed, right? But we got A here. we got this one here. So see, they will get precedence. That's one thing. But what you are calling MRO test here. So when you are calling MRO test from D, okay, D is the one main one. When you are calling this one is present here, one is present here. Okay. So if you have problem here, then you go to here. Then order of precedence will not work. You check the difference between this one and this one, this one. You will be able to know. I'll send you the file. Then this is one, class A, then class B. Only name and age are written here, self ID. And we have one here like this, one initialization and one method. Now C is a child of A and B. Now A dot init. Remember, you have two choices. You can write super or you can write the parent name. That is also there. These are parent names. But remember, when you write parent names and you try to go there, you have to write self within. I'm not discussing here the difference, but remember, if you want to use the parent name here, that is also possible, but you have to write self. We have never written self here in super. You check here. You can check later, okay? In super, we have not written self. This one you need to check. Then when you call this one get name, okay, what will happen is get name comes here, self dot name. So if you see self dot name, you got John or Richard. That's what you need to observe. Now A dot init, B dot init here. So you created one C. The recent one is this one, because once you get one, then that will be erased next time. That's how you got this answer. Make it a point to always write this way, because in many other IDs it won't work. Now I'm not going further. Let me reveal something here. This class is optional. If you have a career, you want to make a career in data science, machine learning, artificial intelligence, you have a whole lot of things to do. But this class is not required anywhere. However, for completion, I made this class for you, and I wanted to complete everything. Even we have something more, isomorphism and little bit of abstraction, not important in Python, but isomorphism is there. I'm not discussing here because it will be more, okay, it will be extended. I fixed 5 classes. I think this much is sufficient. Even this class I'm saying it's optional for you. If you want to do, that's fine. Even if you leave this one, you have knowledge till 3 to 4 class of object oriented programming. That will not create any problem proceeding further. I planned 25 classes for Python programming, and for advanced Python programming 10 classes. I've taken 4 classes, 26 to 29. Then we'll continue up to 35. That will be 25 to 35, 26 to 35 advanced Python programming, and 1 to 25 Python programming. So what we have done till now, whatever I wanted to complete in object oriented programming, I fixed 5 classes, and almost I've completed 80%, 85% of object oriented programming. Even this much more than whatever is required for your career. Even if you do 3 classes, 3 or 4 classes, then also it will be absolutely fine. However, if you have time, you do this class also. You have already attended, just you need to revise. It will not take more than 15 to 20 minutes. That's all. We'll have 5 classes. I will discuss functional programming in the next 2 class. We have some functions like map and all that. They're important. And then the third class will be uh, about some more functionalities in Python. We'll spend 3 classes. And then the last 2 classes, we will discuss different problems. So we'll end Python with 25, 26 to 35. That will be object oriented, sorry, that will be advanced Python programming, where you have NumPy, Pandas, and Matplotlib. Then after 35 or 38, maybe 37, it will go. I can say now. After that, we'll have another 6 to 7 classes. There I will discuss some data science problems, some applications of Python programming, you can say. And you must be knowing I have another group where I've started machine learning parallelly, and I've given some classes already, and I'm continuing there. Once these things are completed in this batch, those who are here and not there and you want to do machine learning and deep learning, then we'll continue here and we'll do those things once again. That's how we'll proceed. So class is over for today. Thank you.
Thank you, sir.
Okay. Okay.